This talk is about some of these things up here. It's mostly about models and a little bit about what we do with them. I am not qualified to give this talk. I am not an expert. I have a lot of imposter syndrome. I am not an academic. This guy is qualified to give this talk. That's the United States Air Force, Colonel John Boyd. He came up with a little idea called OODA. Can I see a show of hands for how many people have heard of this before? That is a large number. OK. So OODA stands for Observe, Orient, Decide, and Act. That seems self-evident what that is. All right. It's closely related to some ideas by this guy named James J. Gibson. Can I see a show of hands about how many people have heard of this guy? Oh, that's a smaller number. Now it's going to get interesting. So James J. Gibson was a contemporary of Boyd's. I have no idea if they knew each other. But he taught and studied psychology. He came up with this idea called affordances. How many people have heard of what an affordance is? That's a little more than how many people heard of Gibson. So the best way to explain an affordance is through examples. This little bit of stage right here affords me the ability to walk in any direction unimpeded until I get to right about here, in which it affords me the ability to fall flat on my face and make everybody laugh. So an affordance is not a thing. It is a relationship between me as an organism and the environment around me. It enables me to do things. It's the possibility of doing something. Now, the interesting thing about affordances is that, at least in the way Gibson approaches it, it connects cognition, or your grasping of the world, and action, or your doing in the world. The way he sees it, the whole reason you are able to see and hear and smell, etc., is to discover the affordances in the environment around you. And the whole reason you act in the environment around you is to unlock new affordances that you can then hear and see and taste and smell, etc. And you just keep going in circles in order to stay alive. Now, OODA is basically the same thing, except it's in a specific context. So it's the cognition action cycle that is central to any organism's attempt to stay alive, recast for a particular purpose. So as OODA is to cognition action, there must be something that is like an affordance. That something, as I tell it, is how do we go from observation to orientation? How do we go from orientation to decision? It's the connective tissue between the steps and the elements of the cycle or the loop. Well, we are a certain kind of thing, human beings with a certain kind of brain, and the way that brain works in the world is by building models. We build models. We put observations that we make into specific kinds of models. We ignore observations that do not fit our models, frequently called model blindness. We orient with models, and we orient to models. So we take our observations, we put them into models, and that's how we understand the world. And what we're understanding is itself something we have modeled. So given that we're dealing with models all the time, what tends to happen is we only make those decisions which fit within the models that we're using. And we tend not to make decisions that are outside of that framework, or aligned to a different model, or aligned to someone else's model who sees the world in a different way because they're using a different model. And we model all the things. We model ourselves, we model each other, we model what we can do. I model what you can do. I model what will happen when I do something which will change what you can do. Back to OODA. The way most people talk about OODA is that the faster you go, the better. I refer to this as the cargo cult version of the idea, because it says uniformly speed is good. This is predictably what you get when you do second, third, and fourth-hand readings of something. Boyd had a slightly more subtle description. What you want to achieve is to operate inside, in his case, the adversary's timescale. Now, what that means, and this is going to be my longest little slide by far, what that means is that, say in step 1, I get through the OODA cycle or loop before the adversary gets past decision. I have short-circuited and blunted their impact in the world by changing the world around them before they've acted. Say I get through the cycle before they get to a decision point. At that point, they haven't even arrived at acting, and maybe new information has come in that's prevented them from even getting to that point, and they have to start over at the beginning and start observing again. Say I continuously do this. What happens is that the adversary cannot even get through orientation. It's disorienting. The world around them changes faster than they can grasp it. And if you do this continuously even beyond that, you basically frustrate your adversary's attempt to do, see, understand, or comprehend anything, and they will begin to flail. You have effectively, at that point, won whatever winning is in this situation. The way I like to think of it is that you are moving forwards in time, while they are either static or moving backwards in time. So you are playing a new game, and you are playing the actual game because you have changed the game which is being played, while the adversary is playing whatever game they had 6 steps ago. Another thing that Boyd said was that all parts of the loop are not made equal. There are differences between them. I split them into observation and action, and orientation and decision. So observation and action are fundamentally physical processes. Your eyeballs can only work so fast. Your neurons can only transmit data so quickly. At some point, you will hit a hard limit. Actions are also physical processes. You can only move so quickly or optimize movement so quickly. At some point, you will hit a hard limit. However, orientation and decision are fundamentally mental processes. And as far as we know, there are no hard limits. So 2 equally matched opponents can conceivably keep outdoing each other in the process of orientation and decision, even if they hit the limits of observation and action. Which brings me to this guy, Frank Portnoy, who's a professor of law and finance. I don't know why he wrote a book about something else, but he did, and it was fascinating. And I refer to his principle as first orienter disadvantage. So basically, he talks about situations in which experts or athletes of some kind or another have optimized action, and that gives them more time to do other things. And those other things are generally observation orientation to arrive at a decision. So expert tennis players, for instance, in the split second that it takes to see a ball and make a decision about how are you going to hit the ball, they spend a lot more time orienting to what's going on and collecting information about the ball than any average player does, because the amount of time it takes him to act on that is highly compressed relative to me, for instance, who was a terrible tennis player. Which relates to this guy, Simon Wardley, who hasn't written any books, but he is kind of like a business strategy guru. And he points out, amongst many ideas, that in any given system, in any given large system, you have multiple things going on simultaneously. Different parts of that system will be in different stages of evolution. And each of those stages of evolution for that part of the system, whether it be a part of a product or a microservice or a practice, will work best with its own kind of culture, its own set of methods, and its own speed. It's not clear at all that it is uniformly better to be going faster at everything. There are some things, maybe, that there's more advantage in going faster at, and other things at which there's less advantage at going faster at. But still, overall, it is the case that causing an adversary's model to become invalid or out of date is the primary means by which we win in most contexts that are competitive. The other side of that is that if you take your own model too seriously, that is a risk which will eventually get exploited or just blow up in your face. Financial crisis, as discussed by this guy, who wrote 2 books which are all about models. Black swans are primarily those events that are unforeseen and unforeseeable that cause catastrophic failure of some kind, and the reason they do that is because they do not fit within our models. They are outside of our models. Our models cannot predict them. they're also inevitable because all models are approximations at best. And the kind of models that are unchangeable or do not change or you're unwilling to change create fragility. They confer fragility on whatever it is that's being modeled. So a question always arises, well, can models be made robust? Sure, they can if they can change, if they can learn, if they can evolve, if they can grow as the world around them changes. Further question is, can models be made anti-fragile? I'm not sure if models can be made anti-fragile. I don't think Taleb ever claims that they can. But systems can conceivably be made anti-fragile up to some point, up to some scale. And the way we would have to do that is that the systems themselves would have to be constantly stressed in ways that don't cause catastrophic failure, but do cause them to improve. And the mechanism for improvement is us. It is the brains, the connective tissue, that does the evolving of the system. For Netflix, it's not enough that they have a chaos army. They have a chaos army and an army of brains, people, who take the results of the chaos and produce the response, which is the growth of a better system over time. Forever. This issue of scales and times is inherently important to what we're talking about. Mark Burgess talks about this a lot, especially in this particular book. This is not how he would put it, but this is how I put it. Every model has a half-life. Lower-level models tend to change faster, but higher-level models are based on lower-level models. The invalidation of a lower-level model can cascade downstream, where downstream is up in this case, and invalidate every model that rests on it. That is unforeseen. That is catastrophic. That is, by definition, what a black swan is. So what? Oh, I'm going really fast. I should slow down. So if all of what I said is true and holds, which is not necessarily that it does, because it was a bunch of assertions that I made, if all of that is true, there's an inherent advantage when more things are code, or when everything possible is code. You can instrument observation. So you can instrument a block of code, you can instrument infrastructure, you can instrument platforms to emit events and metrics, which are then collected in what are called observability systems. So you take the observation of a system of any size or complexity, and you scale that beyond human capacity. You can automate actions. So what do you do when something happens? Config management run, or a deployment, or an auto-scaling action. Those are ways to take the time it takes to do an action and compress it, which is something you can only do if the thing you're talking about is in some way code. So you take action and scale it beyond human capacity. To some degree, you can even scale orientation and decision beyond human capacity by virtue of having already done it. So if I've already gone through the orientation and decision part, or parts of the loop, for a known model, where that known model actually holds, then I can automate that and then scale it. If I do all of that, what I have done now is created time. And that time that I have created can be reallocated towards dealing with novel contexts, novel situations, new things, new problems that arise. So I take new gargantuan problems, which I might not be able to deal with if I'm dealing with everything else simultaneously, and I create time for them for the human. Because the human is the only, as far as we know, capable machine of dealing with new, novel, complex problems. There are cautions, of course. All models are wrong, all of them. There's no such thing as a right model. Many are useful, though, in some context. All models are biased. We have biases. Our models are built by us, thus our models are biased, which is why we tend to ignore observed data that contradicts the model. That also suggests that observed data that contradicts the model is the most important kind of data. In fact, it's more important than data that confirms the model, and it should get a higher weight. Models are not scale invariant. Not only are all models wrong, they all break beyond some context, beyond the context in which they were designed, beyond some scale. And there are many kinds of scales. Scales are not just of size or time. Scales can be of rate of change, or of frequency, or of dimensionality. And models that are safe at one scale are not safe at another scale. Something that is true for the next 12 hours may not be true for the next month, may not be true for the next year, but something that's true for a month may not be true right now. People tend to only look at these in one direction, but it's bidirectional. So what do you do about this? First is you have to know the context of the model you're dealing with. For instance, OODA as a model, the OODA loop was designed or arrived at within a particular context. That context is one-to-one air combat. The time scale is minutes to seconds, or seconds to minutes, in which there are no externalities, 0 external factors, and both competitors are equally matched. That does not sound like every environment every day that we all deal with. I would hesitate to apply that model without discretion to all competitive situations, because it doesn't necessarily apply. I would suggest, although I would say that this is not easy to do, but to actively seek to invalidate your own models or the models of your business or the models of your operating environment. They're all built on certain models, have certain assumptions. All those assumptions will break at some point. It's better if you find the breaking point before the breaking point finds you. Fair warning, one slide about my company. The main reason I work at this company is because we invalidate models daily. We give people tools by which they can invalidate all their models. That was it. The final recommendation is to read primary sources whenever possible. It is frequently not possible. We frequently do not have the time. So get as few degrees from primary sources as you can. For instance, Boyd's papers are in the Pentagon. Unless you are in the Pentagon with a certain amount of clearance, you do not have access to them. But people have written books about it where they've gotten access to parts of those papers and excerpted them. Go read the excerpts first, read the commentary later. I would claim that the lessons are far richer, although maybe harder to get at in primary sources. Here's a really big reading list. This is just the beginning. So these are the ones that I've found most interesting over the last couple of years. Of course, all of these slides will be posted, and you will have everything. And to think I was worried that I could not get through 50 slides in 40 minutes. I'm running at half time. So thank you very much. My name is Neil. I work at SignalFX. The easiest way to reach me is via Twitter. I'll leave that up there for fun, just to annoy John. And since I'm early, if you want to go get beer, go for it, or I'll take questions. I can't see, so you'll have to yell. Go for it.
I'll turn on the microphone.
I think Matt's just humoring me because he knows me.
No, that's nothing to do with that. I'm curious, how do you know what sort of model you're acting within, either organizationally or as an individual, as you try to approach either like a personal goal or an organizational goal? How do you start understanding what model you're existing within and what your other options are if you wanted to recognize that Ooda is not actually appropriate since it's more of a David versus Goliath situation?
Run headlong at something until you hit a wall. And then you'll find one boundary condition for your model and just keep doing that over and over again. So I don't know any easy way of discovering your own models or the models that you're functioning within other than to push against them, which is the natural way of discovering what your constraints are. So push on things until you find things that won't move anymore.
Hi, I have a basic question. So
Yeah.
these days, looks like everyone is behind big data and trying to find models based on the past historic data.
Yes.
So how is your company fitting into or breaking that mold, right?
So I won't answer that question for my company since this isn't a talk about my company, but I'll tell you how I feel about that. How about that? Predictive models based on historical data have limited use unless you know for a fact that you are within the constraints or boundary conditions of that model. So, for instance, there are lots of things that look like they have Gaussian distributions that only have bell curves in like 1 hour or 1 day time blocks. But if you look at a 1 year time block, you have nothing that looks like a bell curve. What you have is a log distribution that happens to have a bell curve in one part of it. So the scale at which you look changes which model applies. So I would say that predictive algorithms can conceivably get better over time with ever more data, but that requires ever more computation, and there are limits. And they tend to produce a lot of false positives because of that. That has nothing to do with my company or what my company is going to do with predictive algorithms. That's just me.
I have a question about dynamically error-correcting models.
Yeah.
Think of Markov chains and
Yeah.
Markov models.
Yeah.
So on those lines, if Colonel Boyd was in a X-wing fighter instead of a F-404,
Sure.
was that the Lightning, and reaction time, everything changes.
Yeah.
So it takes a totally different angle. And how can you quickly adapt with error correcting in a dynamic model? What's your viewpoint on that?
So as far as I know, the only thing that can do that is us, and that's only within certain constraints, especially if you're dealing with a three-dimensional space and not a simple two-dimensional space. I don't know, maybe someone has built an algorithm that can do that, but I haven't seen one. Presumably someone has. Do you know, John?
Oh, I don't know the answer to that question, but since we got some time, can I ask you, what's an error?
An error is maybe an error for you, may not be an error for me. So it's relative.
So, where's the chain come from?
So it is the case that you always have to give it a goal, right? So if you know that there is a goal to be reached, then you could conceivably build such a model that works. Or yeah.
So I can't phrase this as a question, but
Okay.
I'd like to posit that that sharing your models with the other people that you have around you is a good way to counteract some of your own biases, and having a diverse organization helps that.
Yeah.
I have no question behind it.
Yeah. I would say that inherent to seeking model invalidation is seeking things that invalidate models, and that tends to be stuff that stirs the pot, which is frequently diversity of views, opinions, ideas, backgrounds, cultures, practices, etc. Because that's more things to run a model through that might break it. So the more of that you have, the better. I would also say that diversity is an intrinsic good for this reason, because it produces better results from biology on up.
Good one. Any other questions? That's it.
Next time I'm going to do 2 times the number of slides as minutes I have.
Bridget.
Okay.
You gave us a pretty big reading list. I didn't see a book from you or one from Allspa on there. Who's going to write one in this topic first?
Probably him.
You got to read all of those first.
They're not that long. He'll send them as PDFs to everybody. It's your Oprah gift.
So, I think that's illegal for some. See me in the hallway. Any other questions? Thank you.
Cheers. Thank you very much. Go have a beer.